Very good morning, students. We will continue the linear inequation, and here we will know the graphical representation of a solution set that we are getting after solving a particular linear inequation. So suppose we have a solution set. Let's see, this is one of the example of a solution set given here. For solution set for x is 0, 1, 2, 3. So in a number line, like this one is the number line, you can see a two-headed arrow. Two-headed arrow means the number may be more than 4 and less than -2. That means the number can be exceed to 4, like 5, 6, 7, 8, 9, 10 up to infinity, and here it can be less than -2, then -3, then -4, like that. Okay, so here as the solution set given us 0, 1, 2, 3, 1, 2 and 3. So first here 0 is marked, you can see here 0 dotted, a solid dot is given here. Yeah, and the at the 3 another dot is given. Okay, but remember that the dot should be solid. Okay, a dark dot should be given here at the particular 2 number in the number line. Okay, so this is the graphical representation of this particular solution set 0, 1, 2, 3. Let's see one more example here. Yes, see, if the solution set is with infinite solution, that means it is not ending at any point. Like here, see, this is the condition given here, x is greater than equal to -2. So that means all the values are possible for x which is greater than -2, and with the -2 is, as it is greater than equal to, so -2 is also included here in the solution set. And the condition is given here that x belongs to the integer, that means the integer, so any of the integer we will take, but we will take all the integers greater than -2 and including -2 also. So see, this is the solution set. So here we have an infinite number of solutions. Why? Because if we take greater than -2, then after -2 there will be infinite values. Okay, like here we have ended with this 5, there will be 6, 7, 8, 9, 10 continues. So there is infinite solutions here for this particular solution set. So here see, x equal to, this is the solution set, -2. See, as the condition given here, x is equal to -2 or greater than -2. So x is -2 and greater than values like -1, 0, those are greater than -2, 5, 6, 7, 8. So here to represent this one in a number line, see, this is the graphical representation. Here we have this is the number line, -4, -3, 2. So as the solution is started with -2, so we will mark here -2. As it has infinite number of solutions, so we will dot every point, like here -2 is marked. Yeah, the solid dot is given here in -2, in -1, in 0, in 1, in 2, in 3 we can give, in 4. So it should be infinite, that means there should be infinite dot, but we will not put that much number of dot, but we will just put a arrow sign here. Okay, in the number line we will give a arrow sign. This arrow sign represent that there will be infinite dots. Okay, that means the number that solution set has infinite solution. Okay, correct. So this is the graphical representation of this particular solution set given here. Now see the next example, a solution set for x when, see, this is a special condition here, x is given less than 7/2. This is a fraction. Okay, but one more thing is given here, x belongs to whole number, that is w. So remember that whole number, natural number, integer, these numbers, like suppose if you are considering 1, 2, 3, so this is the natural number. So in between 1 and 2, whatever the number, like in between 1 and 2, half is there, half will be there, 1/2 will be there, 1 and 2, there will be 3/2 actually. Okay, in between 1 and 2 there will be 3/2. So we will not consider 3/2 as the natural number, we will consider only 1, 2, 3, like that. Understood? So here we have w. W means the whole number. Whole number started from 0, then 1, then 2, then 3. If I say here in between 2 and 3, there is a possibility of a number like 5/2 we can put. That is 2 and half, 2 whole 1/2. But this 2 whole 1/2 is not a whole number. Is not a whole number. Correct? Is not a whole number. So here, as x, yeah, see the solution condition, it is given here x is less than 7 by 2, so we can write x is less than 3 whole 1 by 2. So we can consider 3, but this 3 whole 1 by 2 is not a whole number, but it is given that x is less than 3 whole 1 by 2, so we can include here 3. Okay, and see the solution set is given here, x is 0, 1, 2 and 3. Okay, we can't take 4, this is only because x is less than, yes, see this one, x is less than 3 whole 1 by 2, so that means we can't take 4, but we can take 3 because x is less than 3 whole 1 by 2. 3 whole 1 by 2, that means a number which comes after 3. Okay, here 3 whole 1 by 2 means this particular position, but here we have taken 3 as because x belongs to whole number, so we will consider only the whole number. Okay, it will be either 3 or 4, so 4 we can't take because x is less than 3 whole 1 by 2, that means x is less than 4, correct, so we have taken up to 3. So in this way one more question is solved here. Yeah, see, solve and represent graphically, this is the question. This is on the question from the exercise. 7 whole x plus 1 is less than 5x plus 10 and x belongs to whole number. So let's see, first we will solve this. We have 7 whole x plus 1, so for the LHS part we can multiply this 7, so it will be 7x plus 7. This 7 into 1 means 7 and 7 into x means 7x. Here we have 5x plus 10 in the right hand side part. So now we will first vanish out this 5x for separating the variable that you know about. So we will subtract 5x from both the sides. So as 5x subtracted from this side as well as from this side. So here 5x cancelled and only 10 left on the right hand side. See, and here 7x minus 5x is 2x plus 7. Okay, so we have 2x plus 7 is less than 10. Now this is the condition. Now this 7 gives the trouble, so we will subtract the 7. As you all know, subtract 7 from both the sides. So here we have 2x plus 7 minus 7 and 10 minus 7. This 7 is subtracted from both the sides. So 7 cancelled. So in the left hand side we have only this particular 2x, correct, and here 10 minus 7 means 3. So now we have 2x, this 2 gives the trouble, and we know here we can divide this 2 from both the side, in both the sides. So here divide both the side by 2, both the side of the linear equation divided by 2. Here 2 is a positive integer, positive number, that means we are dividing with a positive number, so that's why there will be no any reversing sign, no any reverse in the given sign. Okay, so the sign will be as it is. As you know, if we divide with minus or negative number, then we will reverse the sign also, but here the thing is very simple, that we are dividing both the side by plus 2, positive 2. Okay, so here this 2x divided by 2 and this 3 divided by 2. Yeah, so this is the right hand side, left hand side part, so 2 cancel, so x, and in the right hand side 3 by 2 means 1 whole 1 by 2. So x is less than 1 whole 1 by 2, and x, as x belongs to w, that means whole number, so we can't take more than 1, we can't take the value more than 1, that means we can't take 2, but we can take 1. So 0 and 1 are the two numbers that comes in the solution set, 0 and 1. So if we try to represent this one in the graphs, so see here the graph we have. So this is all for today. Thank you, class.